Hey guys, welcome back to ThinkLink TV, back with another ANSYS tutorial, and this FEA practical is based on thermal analysis of step bar. So let us take an example question. You can pause the video if you want to note it down. So let's get started. First of all, open the mechanical APDL software. If you haven't installed, you can go to the first link in the description to successfully install ANSYS 16 software into your PC. First of all, go to preprocessor, then select structural and click OK. Then go to preprocessor, element type, add, edit, delete, click on add and select link 3D 180 and click on OK and close the tab. So after defining the link, we need to give the volume of the step bar. So after element type, go to real constant, add, edit, delete, click on add, click OK and type the cross sectional area value of material 1, that is 90 in this case, and click apply. And now type the second cross sectional area value, that is 120 in this case, click OK and close the tab. We will be taking all the values in mm and newton for our convenience. So after defining the volumes, we need to give properties to the material. So after real constant, go to material prospects, material models, click structural, linear, elastic, isotropic and type the Young's modulus value of the first material, that is 200 into 10 raised to 3, and assumes the Poisson's ratio as 0.3 and click OK. Also in the question, the linear expansion coefficient of both the materials are given. So to apply for the first material, go to thermal expansion, secant coefficient, isotropic and type the linear expansion coefficient of material 1, that is 11.67 into 10 raised to minus 6 and click OK. Now to give properties for the second material, go to material, new models, make sure it says 2, click OK and select isotropic under elastic and type the Young's modulus value, that is 100 into 10 raised to 3 and assume the Poisson's ratio as 0.3 and click OK. Now go to isotropic under secant coefficient and type linear expansion coefficient of the second material, that is 23.6 into 10 raised to minus 6 and click OK and close the tab. So after defining the link and the properties to the material, we need to create the model. So after material props, go to modeling, create, select nodes, inactive CS, and now consider our step bar in the coordinate system. You can note down this as well. So now type node number 1 and location as 0 and 0 and apply. Then type node number 2 and location as 200 and 0 and apply. And now type node number as 3 and location as 450 and click OK. So after plotting the nodes, we need to join the links. So after nodes, go to elements, element attributes. So for the first link, make sure all the box is 1, click OK and go to auto numbered through nodes, select the first 2 nodes and click OK. Now again go to element attributes, change the value to 2, click OK, then go to through nodes and select node number 2 and 3 and click OK. Now if you scroll up and down, the elements would get disappeared. So to permanently display the elements, go to plot, select elements, and now you can zoom in and out. Now to display the volume of the step bar, go to plot control, style, size and shape, select display of element option and click on OK. So now after making this model of the step bar, we need to apply the forces and the reactions. So after preprocessor, we need to go to solutions and now we will apply the initial and the final temperature. So go to define loads, settings and select reference temperature for typing the initial temperature. So type the value as 30 in this case and click OK. And now to give the final temperature, go to uniform temperature and type the value 110 and click OK. So after defining the temperature, we need to apply the forces and the reactions. So click on apply, structural displacement on nodes and select node number 1 and 3 and click OK. Since both the nodes has fixed reaction, we need to constrain all the degree of freedom. So select all DOF and displacement value as 0 and click OK. We also have a force acting on node number 2. So after displacement, select force on nodes, select node number 2, click OK. And since the force is in positive x direction, make sure you have selected fx and type the value as 50,000 and click OK. So after defining the properties, modeling and applying the reactions and the forces, we need to generate solutions. So after define loads, go to solve current ls, select OK. The tab says solution is done, so close all the tabs. So after solution, go to general post processor, plot results, contour plot, nodal solution, DOF solution, displacement of vector sum, and click OK. And now you can see the thermal stresses induced in the step bar. So to display the results, go to list results, nodal solution, displacement of vector sum, and click OK. And you will get the displacement value at the node 2. Now to display the stresses, go to element solution, select stress, x component of stress, and click OK. And you will get the stress value. We'll keep it aside. So there you go, you have the stresses and the displacement value as per the question. So there you go, you have completed your 6th FEA practical. You can check out my previous ANSYS tutorials, the links will be provided in the description below. So that's it for now for this tutorial. Hope you like this video. If you have any specific question, do post in the comment section below, and don't forget to smash the like button, and do subscribe for my channel for further ANSYS tutorials. Bye bye.